Welcome everybody to URC 2017 participants. Welcome to our seminar. This is Protocase's webinar on how to utilize metal fabrication services for your Mars Rover design. My name is Doug Milburn, and I'm Vice President and co-founder of Protocase. And with me is Christa Carey.
Hey.
And Christa is our Manager of Engineering and Design Services. So thank you for attending. Outline of what I'm going to talk about today. Really quickly, I'm going to go over who we are at Protocase and why we sponsor URC. And I'll quickly get into the details of what we're offering in terms of sponsorship to URC participants, and then that process of how we acquire fabricated parts. At that point, I'm going to hand things over to Christa, and Christa is going to go over everything you need to know about how to design, how to get to a manufacturable design, and get to the parts that you want to make your rover go. So, Protocase. Protocase is, we're about 14 years old at this point. We were once upon a time a startup with one employee. We are now about 125 employees. We have about, over 10,000 customers, probably about 12,000 customers at this point worldwide, who range from what's universities and research, science and engineering and innovation. They range from small startup companies, universities, university research, to all the aerospace giants, Google, Apple, Microsoft, you name it. Basically any name in technology these days. Protocase was built around taking the work that nobody in the metals industry really wanted. Electronic enclosure, sheet metal parts, machine parts, and science, engineering, innovation. When you're building the first of something, you don't want large quantities. To the rest of the industry, there's not much money to be made in it, and there just wasn't really anybody to take our orders. When my business partner Steve and I started the company, it was really our own pain in trying to buy things. Some places have some of your university teams have access to great university shop support, and if you have that, that's great. We're still relevant to such organizations because one of the problems that happens to those organizations is that if you've got a bunch of creative people and you're spending a whole bunch of effort designing things, well, your university shops get loaded up pretty well, and there tends to be some large weights on them. So we do a lot of business with people who, in organizations who have great facilities, and we're really an adjunct to that. Because the work nobody wants, small order quantities, and the other thing, when you're doing a project, there's not a lot of time in a innovation project to sit and come up with what you want to order and then send it off to somebody and wait 6 or 8 weeks to be made. So we are ultra fast. We build things from the time you sign off on a design. It's typically built in 2 to 3 days. There's caveats on that. I'm going to talk about those, but it's very, very quick. So the idea in Protocase is to go from your creativity as a scientist or engineer, get those ideas down in a design, and get them back to you as fast as possible so you can get on with doing what you're doing. Again, the point, we're going to make parts for you as part of the rover project, and it's not those parts, it's getting those parts, getting them together, testing your rover, figuring out what's going wrong, getting a couple iterations in before you're there. So we're one very small part of that. So that's why the speed is important. How do we do it? We pioneered something we call rapid manufacturing, no backlog-free manufacturing. Most other manufacturers like to keep a bunch of backlog, keep work there. We've married principles of lean manufacturing with mass customization to be able to build these very small orders very fast. The other thing we've done is we've worked to improve and streamline the design process. And again, we'll talk about that. So why sponsor URC? We sponsor URC because, number one, are very, very interested in supporting that next generation of scientists and engineers that are going to come out and are going to be taking things over eventually. And these competitions, this competition in particular, really it's a lot of energy into it. And I think it's, we've just been, well, we find it inspiring to be part of it. And the other side of it, we like when we can introduce people into the whole new place that you can take your development if you have access to really, really rapid, simplified and rapid making of parts. So we want to get you that introduction to our whole process and what it means. And as I said, we're very, very happy to support it. We've done it in past years, 2 years previous, and it's been an absolutely wonderful experience for all of us, both us and the team participants that we've worked with. And some of you may have been to the Mars Desert Research Station, Utah already. If you're not, you're in for a really great experience, a lot of fun there. So what's in it for you, URC participants? We're offering $2,000 of free manufacturing services. And anything that you want to go beyond that will only cost you 50% of the normal price of it. And the other nice part of this, you guys are all working within a budget. It's one of the things gets easier if you have an unlimited budget to build a Mars rover, and you, the URC participants, are doing this within a very tight budget constraint. The parts that you get made by Protocase do not count towards your budget. So keep that in mind. That economic side of it's very, very important. And so you get to experience that combination of 3D modeling, precision manufacturing, done at speed and with support. And by doing that, again, some teams you're going to have really great facilities anyway. Other teams, student teams, and back when I was in university, students were great for cheap labor. So you go to a project like this, and things would be done manually. You wouldn't have any options. So spend a lot of time cutting, drilling, banging on metal with hammers to try to shape it and drilling holes in it. You get something that's okay later, but it's not. This allows you to get up on and think more, and just think on a higher level. Think on the level of the problem you're solving, and not down in the minutia of getting the problem solved. So getting away from cheap labor, important part of this. What do we make? Protocase custom electronic enclosures. We start off making custom electronic enclosures. We had this really rapid production business model. Science and engineering community very quickly said to us, well, if you can make enclosures, can you not make fabricated sheet metal parts? So we do custom electronic enclosures and precision sheet metal parts. Recently, starting about 3 years ago, we started to do the same thing in CNC machining. So providing on-demand machining, get it designed to us, and again, typically, if subject to the caveats that I'll talk about, can be built in 2 to 3 days. And there's some other miscellaneous parts and services that I'll talk about as we get a little further down. And if you look at some of the photos here, these are some pictures of the wide variety of things that we do. Here's some fabricated parts that are, actually these parts are part of enclosures. CNC machining, we do 3-axis milling, and actually Chris is going to talk about more milling and turning. Really encourage you to think sheet metal parts as you design rover. This is actually from a FIRST robotics competition team that we've been supporting for a number of years, and these are parts they designed. And machine parts, people often think machine parts first in this place, that machine parts are optimum solutions. Designing in sheet metal takes a little more creativity. There's a little more constraint to it than there is in machine parts, but the whole chassis and structure of a rover can be built. The same constraints that make it a little tougher to design in sheet metal actually help you optimize. It can help you optimize for weight and structure. So you can really build a great rover largely out of sheet metal. And again, not to say that you're going to have a decent sized number of parts that'll be machined and they work together. So keep that in mind. Manufacturing stations at Protocase. We have the following: laser cutting of sheet metal, 3 and 5 axis milling, and we say milling and routering. Routering is 3 axis milling, but just on large sheets, so we can take sheets up to 4 by 8, drop them on a router, and do precision 3 axis milling on it. CNC turning and with live tooling. So turning and lathes, assuming most people would understand what that is. Live tooling is when you basically add milling in. You stop the part and you put a milling tool into the parts. So save setups. Deburring and finishing, tapping, countersinking, and secondary machining on sheet metal. Forming, so making bends. The bends that we make are all linear. So they're and the process we use press brakes and folding machines to do our bending. Self-clinching fasteners are really useful. Christa's going to touch on those. You really should wrap your head around if you don't know what self-clinching fasteners are, because they're a really wonderful little item. If you understand before you start designing, you can save yourself a bunch of time and money. Welding and finishing, such as powder coating and the addition of graphics, silkscreen and digital printing. Okay, how to utilize our sponsorship. So the following steps: attend the Protocase webinar. But if I'm talking to you, I'm assuming that I've already got that one going. There's a Rover Design Tips PDF that I believe was sent out yesterday. That's to Chris. Chris is nodding over there. And get in touch, info.protocase.com. You're going to get in touch with your account manager. That your account manager will be your point of contact through this whole process. Once you feel that you have a design that you want to talk, and feel free to get in contact with our account manager before you even have your parts, your mind wrapped around the parts. You don't have to, but feel free to make that connection. And again, they're there to look after you and make this whole process easy for you. Once you have a design, send your design to your account manager. Your account manager will have a look at it, and they'll review it, and they'll work hand in hand with Christa's group, Engineering and Design Services. Engineering and Design Services will look at it in depth and either get back to you about manufacturability issues. We also, with Rover teams who don't have a lot of experience in sheet metal, necessarily in sheet metal machining, we'll spend some time on optimization with you too. A lot of times it's good to talk about what you're trying to achieve. Sometimes it's straightforward parts, they're simple parts, but other times it's not, and there's some optimization that we can do. And again, don't forget, and now, but for your whole career, when you're getting parts fabricated, you understand the design. There are people are doing the fabrication, understand the constraints of the fabrication process better than you do. So it's working together, and we're a deep believer in that working together. And when you do that, we can get something that's easier for us to make, and it's therefore less expensive and quicker for you. So please, we encourage you to engage a little bit with our team. Okay, so Chris, I'm having a hard time here. Thank you. So after you've sent a drawing in, you've gone over optimization, et cetera, you're going to get a quote back. And once you're good, you say, and we all agree this is what you want to build, you need to approve that. So we have something called e-drawing approval process. So you're going to get back a final electronic copy of the part you want. And then what you need to do is you need to go over it very carefully for all the details, because that's what's going to be built. Okay. So once that's built, it will be manufactured, I'm going to say, typically in 2 to 3 days, and then it's shipped to you. Okay. Price of shipping is included in all orders. Customs is not. I think most of the time, and if you're in Canada or US or Europe, don't worry about it. You won't have any. Sorry, take that back. I'm not 100% sure for Europe. Anyway, some of the other international countries, talk with your account manager about it. But anyway, you're responsible. If you have to pay duties, you're responsible, and there's ways that we can put in custom invoices to get it through without in most countries. Okay, you will receive a pro forma invoice, okay, that's stating the value of the work. So you need to hang on to these and submit these as part of your budgeting, as part of URC. Don't forget, it doesn't count towards your budget, but it needs to come in anyway. Any questions or problems along the way? I want to emphasize that your account manager's there. It's your point of contact. They're there to make life easy for you and smooth things out. How to maximize your budget. Okay. Stay within stock parts and materials whenever possible. Okay. If you go onto our website on protocase.com, and I think we're going to give you a glance at that towards the end of this, there's a great listing of all the parts that we stock. If you order off the menu, they're in the building at the time the order comes, and they're both less expensive, and you will make the 2 to 3 day, you'll qualify for 2 to 3 day. If you need something that's not there, okay, we have processes, we order stuff and we do it normally. We do all kinds of weird and wonderful stuff for people and all kinds of weird and wonderful materials. All that said, it takes time. It's going to add to your lead time for us to order it and have it shipped in from somebody else. So it's going to take you a little bit of time, and typically it's a little bit more expensive because we've got to buy full batches of things. Okay. Sheet metal tends to be more cost effective, and anyway, add in CNC machining where you need it. CNC machining is inherently a little more pricey than fabricating things out of sheet metal. Other things, understand, let me change titles here actually in this, making things run smoothly. So understand tolerances. Right off the bat, the word tolerance, there's variance in manufacturing. Okay? We build parts, anybody builds parts, they're not exactly what's drawn. Everybody knows that. So that's variance. You need to understand your design. Number one, the variances. There are manufacturing tolerances. The amount that we will tolerate, we will inspect, and make sure that the variance in our parts is not outside the band that we publish. That's on our website. There's a piece of material in our resources section that goes over tolerances. And the important thing about tolerances, so great, so you know number and you know our dimensions and our bend angles or our CNC, feature tolerances. The most important thing for you to understand is your design requirements. What can your design tolerate in terms of variance? Think those things through. If you think those things through, and you 3D model your rover, and you buy parts from us, odds are extremely good that everything's just going to drop together when you get it. If it doesn't drop together, everything doesn't fit perfectly, I wouldn't be too worried. You're not the first team in the world. In fact, it's the norm, and not the exception to have some things that don't fit. But that's going to take you time. So you want to get as many things right as possible. So understand tolerances, understand what your design can tolerate in terms of variance, understand the variances in the parts that you'll get from us. If you understand that, you're going to have much better time overall. You're going to get your rover going more quickly. And if you get it more quickly, you'll have more time to give it a really, really good workout before you get to Utah. And I'm sure you've heard the grapevine. Well, if you haven't, you're now hearing from me. The teams that give the rover a great workout, you'll find out what's going to break before you get in the desert, and you get to fix it. And don't worry, if you want excitement, something's still going to break for you in the desert, so you'll probably get that challenge anyway. Right. And carefully pay attention to Christa's section, okay? And she's going to go over about how to create designs that are manufacturable. And there's a link in the bottom there for fabrication tolerances at the bottom of that slide. Timing. We all love to procrastinate. I know I sure do in certain parts of my life. It will work against even with our really short lead times. Just because our lead times are short, do not procrastinate. Okay? Get your design done, get your parts ordered, get everything there, get that rover together. And when you're thinking about time, when you're project managing, building the rover, keep in mind drawing approval time. That 2 to 3 days that we talk about is the time from when you sign off, you electronically approve the drawing, to the time it hits FedEx or whoever it's going to travel with to you. Okay. Any time in between from the time your design comes in, any iteration we have to do to make it manufacturable and optimize it, and the amount of time you take it to consider to approve it is time that it's elapsed time. And add in your plans, add in transit time of 2 business days to North America, and for the most part Europe too. It gets there in 2 days. If you're farther afield, then shipping may take a little bit longer. And yep, I think I said it 3 times. Let me say it time number 4. Make sure you get your testing done long before you get your testing done at the university. That's the secret. You want to be successful in this competition. Get it done, iterate, and nothing like good old empirical testing to get you where you need to go. Details of design, so it's time to hand that over to Christa.
All right. Hey everyone. So what I'm going to do today is try to help you get the most out of your URC budget with Protocase and help everything go smoothly, so we don't have too much back and forth and too many delays on your jobs. So the first slide that we have here, we're talking about preferred file format. So Protocase works with SolidWorks as our main CAD program. So if you do have SolidWorks files, we would definitely appreciate to receive those. If you're not using SolidWorks, it's no problem. We have a lot of other formats that we can accept: Parasolids, IGES, Step, Pro-E, Solid Edge, and SAT in the 3D model category there. For 2D, we have DXFs, DWGs, and then we also have Protocase Designer, which is a great tool for designing your enclosures because it has a lot of templates in there for you to start from. It also has a lot of templates for brackets, so it's not just enclosure-based. There are brackets in there as well, so you may find that handy for some of your rover parts. For graphics on your enclosure, Adobe Illustrator is our main program, but we can accept Photoshop, PDF, DXF, DWG, and you can even put your text in your SolidWorks model if you'd like. We can work with that as well. Some other images below: PNG, JPEG, TIFF, and GIF, and a hand sketch. And just a heads up, if you do want logos and stuff on your enclosure, it's a good idea to get us a vector version of those graphics because they tend to print much better than your non-vector type graphics. All right, so talking about units of measure, we work mainly in inches here, although we can accept anything, and it's just a conversion for us in our SolidWorks program, so we can switch over and use whichever units you'd like us to use. Just make sure you tell us what you're using so that we don't end up, drastically scaling your part in one direction or the other on you. For the sheet metal part of things, as Doug spoke to earlier, we do have to incorporate some clearances into our design, and we have to manufacture to a tolerance. So when we send parts into our production floor, you have to give the operator a little bit of leeway in one direction or the other. So we have a tolerance that we build to. So this slide here is talking to our tolerances. And that the amount of variation that we can allow the operator to have on those parts that they're bending. For position of cutouts, in reference to the overall flat part, we can do a plus or minus 5 thou. So that's on the size of your cutout plus the position of the cutout. Once you start to incorporate bends into your design, the tolerance on bending is plus or minus 10 thou per bend. So if you do have consecutive bends, that tolerance will get stacked. And so you want to make sure you're accounting for that when you're incorporating your clearances and things into your design. The bend angle we bend to is plus or minus a degree, and clearance between mating parts is 0.010, so 10 thou per surface. But, like I said earlier here, if you do have stacked tolerances, you may have to add a little more clearance in some places to accommodate that. So just watch out for that. So for sheet metal clearances, if you're designing, say, an enclosure or a bracket to hold a circuit board, you want to mount your circuit board 0.02 inches back from the inside face of your enclosure. For cutout sizing, we have here, so approximately 10 to 20 thou for clearance. I find this varies. It depends on the manufacturer that you're working with. Some manufacturers of connectors actually put the recommended cutout size on their data sheet, which works really well. Other manufacturers don't go that far, so you actually have to derive your cutout from the dimensions of the connectors. So if you are doing that yourself, you may want to lean more toward the 20 thou clearance, but if you're using the manufacturer cutout, you're usually pretty safe to just use that cutout as is, or maybe add about 10 thou to it. The clearance that you're adding, you also want to account for any finishes that you're going to be having on your part. So powder coat is the thickest finish that we offer, and it goes on to your part in approximately a 3 thou thickness, 0.003. So make sure that you do incorporate that extra clearance into your cutouts as well. All right, so for bending parts, this slide here is just kind of showing a little bent piece of metal here and noting the inside bend radius. So when we are talking bend radius with you, we're always speaking to the inside bend radius of the part. So for bend radii, if the bend radius on aluminum parts is too small, you will get some cracking. We try to avoid as much as possible bending the 6061 aluminum because it is very brittle and it will crack. And in order to get it not to crack, you have to make your bend so large that it really makes the part almost useless for you because you can't get your cutouts really close to the bend. So I recommend when you're going with bent sheet metal parts to try to stick to 50-52 aluminum or your steel and stainless steel because those will bend up just fine at any inside bend radii. So let me just run through here. Tooling. Our tooling that we stock lets us bend a bunch of discs, and so Chris is actually going to send around a bend table which has all of the possible inside bend radii for all the materials we stock and the minimum bend value to go along with each one of those. So you'll find that very handy when you do get into doing your sheet metal design, that you'll have this as a reference. This slide here is mainly for our SolidWorks users. So on the left side of the slide here, I have a screenshot of an edge flange in SolidWorks. And you'll notice down under the flange position, I have a little highlighted portion with the red no circle, the do not circle on it. We prefer people don't use that third bend option because we do have to change a bend radii from time to time on parts we receive. If you choose that third bend option and we do have to change your bend radius, it will actually alter the overall size of your part. So if you are working with SolidWorks, just avoid using that third option if possible. For SolidWorks parts, we also would like if you did not dimension to your bend line. So very similar to using that third bend option we see in the previous slide. If you dimension to a bend radius and we change the bend radius on the part, your cutout will move. So always try to dimension to either the inside of your material, the outside of your material, or the edge of your part. Try to avoid dimensioning to the bend line. For U-shape profiles, we're able to bend parts that are the same dimension in the width and the height, up to 3 inches, but anything above 3 inches, and then you want to get into having your height be at least 2 inches less than your width, and that is to allow us to be able to bend it with majority of the tooling that we have. If you do have a profile that's tighter than this, don't be afraid to shoot your design into us and get us to take a peek. There's a chance we would be able to make it. There's just too many of those, I'm not sure the word I'm looking for here, but too many of those odd designs and odd arrangements that we can do to get into trying to give you every possible situation. So this rule here will be safe, but if you do want to go a bit tighter, give us a call, send us a part, and we'll take a look at it for you. For your minimum flange dimensions, we have a variety of different bending options here. Doug mentioned earlier we have press brake bending. We also have folder bending. Those two machines do have different minimums. So depending on the material you're working with, we can send it to one machine or the other. And for different thicknesses, we have different minimum bends. So little right up here, so 0.2 inches for thicknesses up to 0.064 inches thick, 0.275 for thicknesses between 0.075 and 0.081, and 1/2 inch for your min bend for thicknesses between 0.09 and 0.125. Your minimum flange dimension also applies to the closeness of a cutout to a bend. So if your cutout is close to the bend, that cutout must be at least your min bend dimension away from the outside of the material. And in the image in the lower right there, that's showing, so if your cutout does get too close to the bend and you really do have to have it in that position and you cannot accept the cutout maybe stretching or flaring on you, an option is to actually notch the bend out in that area, which will leave your cutout in its perfect form. For hat-shaped brackets, we have a bit of a height restriction on this one. So for material 0.075 and up, half-inch height is your minimum, and for material up to 0.064, 0.29 inches plus your material thickness is your height for that one. And this is the folder that Doug was speaking about earlier. It bends a little different than a press brake, so instead of your punch coming down from above, it actually has a folding arm that can flip up from below. So this is, actually this one is bending on the folder here. Yeah, so we do have some dimensions on here for you. So like I'd mentioned in the couple slides back with that 2-inch rule, on the folder you can see here that we can actually break that rule. So this might be a good reference if you are able to stick with a folder compatible material. We can get into bending some profiles a little tighter than the 2-inch. We actually, in this example here, we have a part that is 7 inches tall and only 3.5 inches wide for a U-shaped profile. This is just an image of press brake forming, so we're just showing our backstop, our upper die, and our lower die. And these are some profiles of the press brake tooling that we're currently using. Some of these tooling profiles will allow you to get into those awkward shapes I was talking about earlier. For example, anything with the gooseneck on the end, so when the tool comes down and then angles out, those will let you get under flanges and things like that. And
Christa, let me just interrupt just to say one thing that Christa's going over this for those who want a sense of how things are bent and what kind of constraints are on there. But there's no expectation that you need to understand the bending process before you send it in. Send it in, and we will worry about all this stuff for you.
All right, so we also have a cutout library. Cutout library is available through Protocase Designer and also on our website. And there's a variety of different cutouts in there for connectors, fans, switches. You can download those. We have DXFs available, SolidWorks files available, and also the Protocase Designer compatible cutouts. So for self-clinch fasteners, so this is a pretty important slide. When you're working with sheet metal, if you tap your sheet metal and it's really thin, you can strip your hole pretty easy. Self-clenching fasteners allow you to put a really strong thread in a piece of sheet metal. We stock a ton of self-clench fasteners. They're all listed on our website. This slide here is just showing a few examples of the different styles we have. So we stock self-clenching nuts, self-clenching studs, standoffs, both in through hole and blind, and then we have concealed head studs and standoffs. So if you're looking for a nice clean look on the outside of your panel and maybe you're not able to see the head of the stud or standoff on the opposite side, you can always go with the concealed head option. The concealed head option does require insertion into a blind milled hole, but we do have all that capability here. So for just one more thing on this one, so for the self-clench fasteners, mounting your circuit boards, so use standoffs for mounting your circuit boards. You can use studs for mounting your power supplies or any other plates that you have going into your enclosure. It's also very convenient for connectors. I see a lot of customers use studs for mounting like those military-style connectors, or maybe you might want to put some self-clenching nuts around the perimeter of your connector so that you can bolt it onto the enclosure. So there's all kinds of different options there, and this is just a very small picture of what we have. We do have a lot that we stock. And so this is just speaking to what I was just talking to there. So your self-clench fastener is going to provide a strong thread in your material. It has a high push-out and torque-out resistance. Reverse side of the sheet metal stays flush. It's low cost, and you don't have to worry about all that loose hardware that you would normally have, which then saves you a lot of assembly time. In CNC milling, so we can machine all kinds of different types of parts. We can even take a part that starts as sheet metal and do some milling on your sheet metal part if that's needed. So we have 3-axis and 5-axis CNC milling, and the work envelopes there are listed, minus some work holding. So we do have a vacuum chuck that allows us to accommodate some flat parts, and we can switch over to a vise or anything else that we need to machine. In these photos here, we're just showing a couple of machined parts. The one in the upper right is a machined enclosure. So if you did have a requirement to completely seal an enclosure, a machined enclosure with maybe an O-ring groove milled in it might be what you're looking for. For mill tooling, we have a couple of different sizes of end mills listed here in this screenshot. We do have some other stuff available as well that we've kind of acquired over the last few years with custom orders in for other customers. So if what you're looking for isn't here, just let us know and we can take a peek and see if it is something we have. So what we're showing in this image is your diameter of cut versus depth of cut. So it's kind of important when you're milling pockets and things in your parts. You want to make sure that the radius that you put in the corner of your pocket is going to be able to be machined, right? So the smaller the cutter, the shorter the tool. So just keep that in mind when you're designing those milled parts. For CNC router, it's very similar to the 3-axis mill. The difference is we have a 4x8 bed, so we can put a full sheet of material on there and machine, a really huge part or a lot of smaller parts all at the same time. Copper bus bars, those are a great way for you to distribute power throughout your enclosure. You can see in these photos here, we can cut them, bend them, just like we can all of our other materials. And these photos also show some self-clenching fasteners being installed there. So if you want to avoid tapping on your copper parts, self-clench fasteners are definitely possible. For welding, some of your parts may require welding, so we're currently offering spot welding, but only on your steel, stainless steel, and galvanneal. For aluminum and stainless steel, steel, and galvanneal, we also offer your tack welding, stitch welding, and seam welding. We use cold metal transfer welding, so you do get a lot less warpage with your regular welding process. And then there's just a couple of different corner treatments shown there in those images. And so for finishes, bare metal finish, which is what we see a lot for these Rover parts in previous years. Most people don't get them powder coated, mainly because you might have to do a little rework on your end. So we offer a no finish. No finish means basically we're just deburring the parts. You could have some surface scratches in there. Grain finish gives you much more of a cosmetic look. It's a bit more expensive than your no finish, and green finish gives you the nice, like a brushed, also referred to as a brushed finish. Tumbled finish, so any parts that are less than 10 by 10 by 10 in dimension, we can put them into our tumbler. So that will just kind of break the edges, make them not so sharp, and it gives it like almost like a frosted look over the part. For aluminum parts that do require good electric conductivity, you may want to put a clear chem film on that. So we do offer that in-house, clear chemical conversion coating. That's for aluminum only. We can powder coat all of our metals. For stainless steel, we'll passivate. We'll clean them using our passivation process. And if you have any copper parts, you have the option of getting those tin plated in-house as well. We have anodizing listed here. We're currently not anodizing in-house, but we do have a great relationship with a local person, so we can turn anodizing jobs around fairly quickly.
I'm just going to add one thing too. Perspectiveness and finish. Most of the time, the budget option is no finish. So you have sheet metal parts or machine parts that you wish to, are going inside your Rover and they're not cosmetic. No finish is your place to go. Second is actually powder coat. Powder coat is very cost effective. So if you need something, outside of your Rover, powder coat is very reasonable. Grain finish, if you really want that brushed, stainless steel or aluminum look, it's there, but it's going to cost you a bit of your budget.
Yeah. All right, and so for graphics, we have direct digital printing and silkscreen as our options. Direct digital printing can only be done on your powder coated parts, so if you are going for a bare metal finish and you do want graphics, silkscreen is going to have to be the way you go. But both look really good when applied to the parts. Digital printing, you can get a little fancier with your logos because you can get a lot of gradients in there and a lot of different colors very close together. in less setups, which on the silk screen, we have to lay every color as its own setup, so logos that have a lot of colors in them can get a bit time-consuming and costly. And that's everything.
Thank you, Christa. And we apologize for the pace we went through that. That's everything everyone knew about sheet metal and touching on machining all in about 20 minutes to do that. And I just want to emphasize, we just want to touch on this stuff. And again, what you should get out of this, a quick overview of what we do. Okay? And the concept that it's not just enclosures, but sheet metal parts, structural parts and non-structural parts, so the sheet metal and machine parts that we can do for you. And that the resources are there. Our website is rich on resources, and anything that you don't have, our account manager will get in touch with and we'll get you the information that you need. So that's it for the webinar portion. We're going to take questions, and anyway, yeah, so questions. So if you look on your control panel, Chris, there's something called questions. That's great. So if you just type in your questions, and we will go through them in order, in sequence. And if we don't get to them at all, we'll stay here for a while. Anything we don't get to, we will we'll answer and send out around as we did the last couple of years. Yeah, and post on the URC Hub. And we really encourage you to use the URC Hub. Make sure you're on there, make sure you're watching it, because that's going to be the prime source for information. Okay, Chris?
Does Protocase sponsor teams from the UK?
Absolutely. Yeah, we sponsor teams right around the globe, actually. Yeah. And UK, we do all kinds of business. We have many hundreds of customers in the UK, so, and likewise around the world.
Will the new updates for Protocase Designer be coming out?
New updates for Protocase Designer. There is a series of updates coming out soon, and just software development, soon is a funny word. If I would suggest maybe 3 weeks, 4 weeks. And for the most part, what's coming out in the next update of Protocase Designer, there's a whole bunch of subtle usability, cleanup, interface convenience things. There's nothing massively enabling, and there's nothing that if you designed right now that you're just not going to be able to do. So.
When the design process is being analyzed, will structural integrity be taken into consideration?
No go. We can offer you some general advice from looking at it. We don't do that. That really is you guys. That's application level. So, if I was going to say sort of a design sequence, get your design together. And, if you have any parts that you have questions on for optimizing whatever, get them in as fast as you can. We'll give you, and then let us know if it's a structural part. And we'll have a look at that, tell us what's important about the part. We will come up with some suggestions, and then that's a good time for you to run it through FEA.
So the next one, they're saying that the link was really long, and they're just wondering if they're going to get a copy of the presentation.
Yes, slides will be posted on URC Hub. Chris? Yeah. Correct? Yeah.
Is there a deadline for the submission of the designs?
No, there's no deadline for submission of designs. You got our timelines, okay? So it's 2 to 3 days. And typically, if you have an uncomplicated part that comes into us, it can, by the time we receive that, let me go over. If you have a Protocase Designer part that's uncomplicated, can be accepted directly as an order, okay? And it can go right into manufacturing, and it'll be out the door in 2 to 3 days, and off to you, typically in 2 days, maybe a few more days. Okay? Add some extra time if it's getting submitted in your own CAD. Okay? If you need non-stock parts or materials, it's going to add time. If there's optimization, it's going to add time. So take that and manage your project. Make sure you do a Gantt chart for your project. Assuming you're doing that anyway, and you can work backwards, and you draw your own deadline for submission of designs. We are by far the fastest thing in the industry. So if you get in trouble, we're there. We help bail you out. But don't work yourself in trouble. Okay? Get it done ahead of time. You're going to need that speed when you get stuff back and you get your first iteration and something fails on you. So don't use it in the first round. Use it to get a few more iterations out.
Okay. So this next one is they're wondering if sponsorship only covers the electronic enclosure, or if they can send us their wheel rims or something irrelated to enclosures.
Absolutely not constrained to enclosures. 100%. Anyway, so enclosures, sheet metal parts, any sheet metal parts, and again, refer back to that picture in the presentation that I showed you from our first robotics team. Okay? Structural sheet metal parts, brackets, mounting brackets, all kinds of things, as well as machine parts. Okay? So anything.
And is the shipping cost included inside the budget?
Shipping cost is included. Any price that's quoted to us includes shipping, and the $2,000, anything up to that $2,000, that's all outside the budget. So.
Yeah, and this is just somebody else again asking if the PowerPoint is going to be provided. So, same question.
PowerPoint will be provided, absolutely. Yeah.
And can you tell us the price distribution of all the manufacturing abilities that are offered by Protocase so that we can optimize our budget? Unfortunately not. It's just complicated, and a lot of times there's things that interact with each other. So, steer clear of non-stock parts, as much simplicity as you can, just like you're using your own internal shop or making it yourself. The more simplified parts, the less expensive they're going to be. And when you come back with a specific part, we can speak optimization with you. Protocase designer might be able to give them an idea if they wanted to play with the instant quote on that. But.
Yeah, and Protocase designer has a whole bunch of enclosures, but it also has bracket templates for, so simple sheet metal parts can be designed in Protocase designer. And you can get a sense, because it does instant quoting for you, you can add cutouts and fasteners and things like that, finishes, and then you can press the button and get a price quote. So that'll give you some sense. But I wish we had some material that we could give you that really answered your question, but we can't. But Protocase designer, if you want to play around with that, can help you.
And does Protocase provide extra sponsorship to certain teams other than the $2,000 for manufacturing, for instance, sponsorship to buy motors, etc.?
Not as such, and again, it would be a little bit problematic for us because in the spirit of fairness, it would be difficult for us to do.
But they do get the additional 50% off of metal parts if they want to keep ordering.
Correct.
Parts.
Yeah.
And will you be sending the raw material dimensions in order to understand what the fabrication constraints are?
We stock, and again, I'm talking in North American units, we stock 4 foot by 8 foot. So what's that, 1,250 millimeters by 2,500 millimeters ballpark? 4 foot by 8 foot is what we stock for sheet metal. We have all kinds of stock for machine parts, a wide variety of it, and I really couldn't tell you much out of my head, and we don't have a stock list, I don't think, on our website. There's a stock list for machine parts?
For machine parts, I think it's just talking about the plate we stock, so we have 3/16 quarter and 3/8 and a possibly half-inch plate, I think is on the website.
Okay. So the rest of it, again, design your parts. First, rough design your parts, and then
we do have, actually, our bar stock is on there. The bar stock profiles that we stock are on the website. Yeah.
Okay, so plate and bar stock are in there, and with machine parts too. We have a fairly fast supply chain, so if you needed something that was in different sizes, it's really not going to throw things totally off. But sheet metal, it's not going to be a problem. I've never seen a Rover that had a part larger than 4 foot by 8 foot, so that would be a large Rover.
So the next person's just asking, they don't understand that, they just want a little more explanation on the 50%.
Yeah. Our sponsorship offer is $2,000, okay? And that's $2,000 that you can use that's in addition to your URC budget, okay, so it doesn't add in and up your budget when you use it. If you wish to buy more fabricated parts from us, we will not charge you the full price. It's outside the sponsorship. It won't charge you the full price, but we will give you 50% off.
Have you ever shipped parts for URC teams that are anywhere except the Europe or UK, like India, Korea, other places?
Absolutely. Yeah, absolutely. Yeah. We had several teams in India took advantage of it last year. And where else, Christa? Do you remember?
Chris will probably be better. Yeah.
In Bangladesh. Poland. And Poland's in the EU, so yeah. Right.
All right. Will the quotes provided by the account manager in Protocase be almost the same as the quotes shown by Protocase designer, or are there any discounts for students?
No, the pricing you're getting is our standard pricing. So that $2,000 is based on our standard pricing. So sometimes there's subtle discrepancies between Protocase designer and our standard pricing, but they're pretty much the same.
And so last year, this person had their package held for about a month by the customs office, and is there any way to avoid that this year?
Oh boy. The wonder of governments and red tape. That's really miserable when that happens. If we knew the reasons, and it's just, some countries you just get custom delays on, and other countries have smooth custom delays or have smooth custom processes. The biggest thing is to, and sometimes if you mark a package as a certain type of shipment, they travel under supposedly standardized codes, and then there's dollar values that are done. Some countries things can be gift or sponsorship, others can't. The biggest thing we find with customs is if you put anything there that's complicated, you can have a person whose job is to push paper and they really have no idea what's going on, and if it confuses them and it's too complicated, then it'll just sit there. So if you had problems last year, if you know anything about it, please talk to us about it, and we'll see if we can find a solution to it. For the most part, the vast majority, we ship stuff around the world. We are number one in the world in the field we do. We ship stuff. It's just going all over the world all the time. Most packages get there with minimal customs delays. But just sometimes you just, unfortunately, win that lottery, unfortunately, that you don't want to win.
And will the parts be assembled if the design requires rivets and fasteners? And if so, what are the safety measures taken during the shipping of the product?
We would typically, when we ship things, if there's an assembly is obvious to us, they will get assembled. And if we assemble something and look at it and say, if they're going to be awkward in shipping, they'll get taken apart before they get shipped. We take great care. Things are heavily bubble wrapped and put in, proper boxes. And if you have something that's awkwardly mounted that's going to be stressed by vibration and shock and shipping, they will be taken apart and wrapped separately.
And do you know what the transit time to India is?
Not offhand, but it's not unreasonable. Our default shippers, Federal Express, it moves by air, and I'm going to guess that it'd be on the order of 3-4 days.
Mm-hmm.
Christa,
that would be my guess too, but the account manager could give them more info on that for sure.
Yeah, speak to your account manager. We have lots of experience in shipping to India, so so they'll have an answer for you.
And so this person here, they lost audio when we were answering another question, but you just answered it 2 questions ago, so I think they probably got the answer.
Will parts be assembled if the design requires fasteners? Yeah, let me try that once again. And again, if you don't catch it this time, we assemble things first to make sure that they fit. Okay, and some things are best shipped assembled. Other things are best not assembled. So we will figure out what the best way to ship it is to get it there safely and ship it that way. So yeah, there will be test assembled if it's obvious that they belong to an assembly, and then if necessary, they'll be taken apart for safety and shipping.
And our team uses Autodesk Inventor software, and so that's their Inventor format. They're wondering if that's okay, or they should convert to STEP or IGES. So if you're using Inventor, I'd recommend either sending, we prefer Parasolid because it's a bit more of a stable format than your STEP or IGES, but Parasolid, STEP, or IGES would be fine, but we do have trouble with Inventor files. And what kind of materials will be allowed? Is it restricted to only sheet metal?
If they're sheet metal parts, it's going to be sheet metal. And if they're machine parts, we can machine sheet metal or we can machine other stock. So bar stock and plate stock. And again, we spoke about that before. If you go to our website, there is information on the bar stock and plate stock that we keep. And if you have questions further to that, please just get in touch with your account manager. Your account manager will tell you.
Can we take products when we arrive in USA for competition instead of shipping to address?
That is definitely yes. We can ship them to the U.S. For teams from outside the U.S. And we've done it before. And things like ship it to a hotel, for example, or any other address that works for you. Now, the only downside to that is you don't get it early to make it part of your rover. But if that is optimum for you, we can certainly do it, yes.
Next one is, what's the price difference between your no finish and your powder coated?
Oh, that's a very good question. It's relatively small, as a percentage of the goods. It's typically, and it's a very. I can't answer the question in general, other than to say it's very small. Yeah. So if you want them powder coated, I wouldn't.
Don't shy away
from it. I wouldn't shy away from it.
No.
Or you could ask to be quoted in either.
Yeah. And do you carry out an etching process on your sheet metal for logos?
We can certainly etch for logos, although the screen printing and direct digital if you powder coat it as well. So, and the other thing we see, and again, if you go back to the slide, there's a slide that I showed with structural parts for a robotics team. Again, I'll refer to that. You'll see that they have their logos cut in the parts. So there's a nice effect to that too. So yeah, use your creativity. You got that. You can etch. Etching is going to cost you, I'd say of all the options, etching would be the most expensive. It's not prohibitively expensive, but it is the most expensive. So you can cut, you can silk screen, you can direct digital print, and etch. So lots of options. Use your creativity.
And what's our tolerance for laser cutting?
Laser cutting, we say for dimensions in laser cutting that we say plus or minus 5/1000ths of an inch, and unfortunately, I can't convert that to millimeters in my head, but it's decimal 0.05.
Right now, 0.125. Is it Cody?
Anyway, 0.005 inch is our standard tolerance. However, the laser, our lasers cut to much better tolerances. That would be an absolute dimension, across a 4x8 sheet. So locally, you'll find that those cutouts are their positions are much finer than that.
That's the last one.
And that is the last question, unless anybody else wants to come in with anything else. Great. Well, we'll take advantage of that pause there to assume that everybody got out all the questions that they wanted. And I'm going to say thank you. Thank you very much for being part of the competition. Thank you for attending the webinar. I hope our sponsorship is useful to you, and we're here to provide a good experience. Please get in touch with us and work with us, and we'll see what we can get and see if we can make your life a little easier and help you get a better rover.
So there's a thank you there, and one more.
And thank you. And is there any way that customs can be avoided in the country? Product Protocase is being sent on the basis of educational users. We do not know very much about the subtleties. We get advice from our customs broker on how to ship things, and we have shipped stuff marked as sponsorship for education before, and I mean it's all there's we've shipped to probably 50 countries in the world, and there are 50 different sets of custom laws, and I wish we were familiar with all of them, but we can't say anything in general. So and you can certainly get in touch with people who know customs on your end. It's something else you can do, and then we can get information from our from our own broker. So great. Thank you very much, and we look forward to working with you, and look forward to seeing you in Utah. I'm going down myself this year, so going to be great.